his Pangaea. He also looked for matching rocks formations, and he could also prove those as well. As you see, we have it here at the western tip of Africa and the east coast of the U.S. Rock fossils or rock layers that match totally, as well as here along the European coastline in Greenland. So he had a conglomerate of evidence that actually was in support of a theory that he actually came up with, and his theory was called Continental Drift. So, and he actually thought that he was on the right page here, and he actually went to New York to one of the large gatherings of geologists in 1928, and he proposed to those geologists at that time that all of Earth's lands were once connected, and he proposed the theory of continental drift. He presented his evidence, and all the geologists were like very in tune with what he was saying until they asked him the question, well, how do you think continents move? And for that, he had no explanation. So he said, and this is why the theory is called continental drifts, the continents must be like ships on the sea, and the ocean must be moving the continents around, and that's how they are drifting from one location to another. So at that point, unfortunately, he became the laughingstock of the Geological Society, and everybody was making fun of him. Well, what the geologists at that time didn't know is that Alfred Wegener was on the right track. There was once a Pangaea, and even though he said it's continents adrift or continental drift, his theory of how plates moved was incorrect, but his actual notion that they did move was correct. So today we actually refer to Alfred Wegener as the father of plate tectonics, because his theory of continental drift truly led to a new theory when more evidence came into play. So that's where we're headed, to the theory of plate tectonics with the father of plate tectonics, our good old Alfred Wegener. So what happened in order for geologists to start giving him more credit? Well, in 1950, scientists actually discovered that they could measure magnetism in rocks and found that continents had shifted in their latitudes. So meaning, yes, he was absolutely correct with his theory of Pangaea. The continents, according to the magnetism that is found in the rocks, had moved over time. And then in the 60s, there were two scientists, Harry Hess and Fred Vines, and they both found evidence that not only is the ocean floor cracked, when we talk about the ocean floor, we're talking about those lithospheric plates, or the crust is cracked. It's cracked into large chunks. So they discovered that if you are in the ocean floor, and they measured this, and along the ocean floor is this massive crack. So here's the ocean, here's the crust, here's the asthenosphere below it with the convection currents. They noticed that the further you get away from this crack, the older the rock gets. So young rock is found in the middle, and the further and further away you get from this crack is older rock. And they named this phenomenon seafloor spreading. And so we're going to get some notes on that in a minute as well. And then, obviously, in the late 60s, scientists started tracking all the occurrences of any seismic activity, including volcanoes and earthquakes. So you can see all along here, and here, and here, and here, and here, and here, and all everywhere, there are a whole bunch of earthquakes and or volcanoes. And if you look carefully, these kind of outline the crustal plates, or the lithospheric plates. Remember, the lithosphere is the crust and the upper mantle, that rock layer. This rock layer is cracked, and you can see where it's cracked if you follow and track volcanoes and earthquakes. You can see exactly where it's tracked. Here is North America, here's South America, here's Africa, here's Greenland. If you look here carefully, there's a whole bunch in the middle of the ocean. And guess what? In the middle of the ocean, that's where Harry Hess and Fred Vines discovered that seafloor spreading, that the further you get away from that crack, which corresponds with this crack here, the further you get away from that crack, the older the rock gets. So new rock is forming here, a new crust. If you remember, here's the asthenosphere, stuff is moving up here, and so new crust is forming along this crack and moving these two apart, and older rock can be found on either side. So that's what's happening here along this mid-ocean ridge, as we call it. It is seafloor spreading. So this is all the evidence in combination with Alfred Wegener's evidence that led geologists to the theory of plate tectonics. And here you can see that the lithospheric plates, or the crust, it's better called the lithosphere because of the crust and the upper mantle, or that rock layer, they are cracked. And they are cracked in the places you see here. So you can actually see that these are called the major plates in here, that they're cracked and they're moving in different ways depending on what the asthenosphere, those convection currents in the asthenosphere, are doing below them. All right, so one of the activities we do is we puzzle Pangaea. So if you followed the instructions, it wasn't that hard to do. What you had to do first is go ahead and cut out your key and then shade it in the colors you intend to color. The best way to do this is actually shading in the different parts of evidence that can be found, and then just puzzling them together once you've shaded it in. So now if you look, I have shaded in all my pieces according to my key. And now I'm just going to puzzle this once existing supercontinent. So that's not going to work because we need Greenland. So I'm going to kind of guide you through it if you need that assistance. Here we have Greenland and Europe. I'm going to slide that in there. That fits right nicely there. So they kind of fit together. And then if you look, North America, looks like I possibly am missing a piece again. Let's go with this first. So South America and Africa fit nicely together. And then Africa joins in here. And that puts South America and Africa right there where Wegener had noticed they might fit together. So we're just adding all the evidence that he found and other geologists found to puzzle this together. Now we have India. I think India comes into play right here. And then, of course, Antarctica. Remember, we said all of this was closely located towards, when they all joined together, these supercontinents, it was close to the equatorial regions. That's why on Antarctica today you can find fossil evidence of plants and animals that could have lived in tropical regions. And then, of course, we have Australia. So this is our Pangaea, our supercontinent, based on the evidence. So you can go ahead and pause this video now to check yours and to make sure that you have everything in the right location. Also, go ahead and label your continents, because that was quite difficult if you didn't recognize their shapes. So go ahead and do that. Pause the video. We also had an attack